Hi, this is Evelyn. I'm here to teach forces, first law, second law. Let's start with what's force. Force is an force can be defined as a push or pull of an object. And for example, when you throw a basketball, you apply to a force to the ball. Force is measured in newtons. The SI unit for force is newton. A force, we have three types of force: the first law of Newton, the second law of Newton, and the third law of Newton. Let's talk about the first law of Newton. The first law of Newton says that you have to learn a new technology here, not net force. Net force is a sum of all forces acting on an object. Um, that's the first law. For example, uh, it's a tug of war when a team is pulling the tug with a force of maybe 100 newtons and other with 80 newtons. The net force will be 20 newtons. It says find the force. If both teams pull the tug with equal force, what will be the net force? If both teams pulls all the forces, what will be the equal force? In this case, you have to find the net. You have to find the net force for for the direction of each team. So in that case, you have to subtract 100 newtons minus 80 newtons. That will give you the direction 20 newtons. That will give you the direction of both the direction of the first team. That will give you the direction of the first team. And let's move to the second law of Newton. Second law. The second law says that Newton law second state talks about an object that has net force. It states that when the net force acting on an object is not zero, the object will accelerate at the direction of the exerted force. Exerted force. The acceleration is directly proportional to the force net and invisible proportional to the mass. It can be impressed in the formula of F equals to mass times A, where the force where the force is the net where F is the net force in Newton, M and M is the mass of objects in kilometers. Kilometers. Where A is the acceleration in meters per second square. Let's give us a question for second law statement. How much net force is required to accelerate a 100 kilometers car at 500 meters per second square? In this case, we have the formula. So we have the mass. The mass is 1,000, and we have we have the acceleration, which is 5.00 meters square. So we multiply this by this, which will give you 5,000 newtons. And let's move to question 2. If you apply net force of 1 newton on 200 book, what is the acceleration of the book? In this case, we have the acceleration and we have the force. We have to find for we have the sorry. In this case, we have the mass and the force. We have to find for the acceleration, and to find for something, you have to find for the opposite of times is multiply. So 1,000 divided by 5,000 is gonna give you 5. So that is the acceleration per square. Anything, um, if anything times and you want to find the opposite side is gonna be division. Let's move to the third law of Newton. The third law of Newton says that When you kick a wall in your room, you will probably end up hitting your foot. Newton's third law of motion can explain why. When one object applies a force on an object, the second object applies a force on the first that has an equal magnitude but opposite direction. In other words, when you kick the wall kicks back with equal force. As a result of, you will get hurt. These forces are called action reaction forces. Remember, when you kick the wall, you exert force on the wall. When the wall kicks you back, it exerts force on you. Therefore, the net force on the wall is not zero, and the net force on your foot is not zero either. So let's have a question here. Let's solve a question on the third law. What is the net force of 200 grams ball when it hits a wall with acceleration of 10 meters 10 meters per second square? In this case, we have 200 divided no 200 divided by 10. So 200 divided by 10, you're gonna get 20 newtons for this one. So that's force. Thank you for joining me. See you next time.